5 pi over 3. I want to get that to degrees. So what do I need to disappear from this problem? Pi. Very good. So I need to multiply that by what? 180 over pi. So what happens to these pi's right here? Okay, and 3 goes in 180 60 times. 60 times 5 is 300 degrees. 135, I need to convert that to radians, so I'm going to multiply it by what? Pi over 180. If I'm going to radians, doesn't pi need to be in the numerator? So I need to multiply it by pi. Okay? What can go into both 135 and 180? 45. Yep. Or you can do 5 and keep reducing. 45 goes in 180. Hold on. 4. And 45 goes in 135 3 times. So that's going to be 3 pi over 4. Okay. Now, this one right here is actually number 2 on the back of your study guide. This is a short answer. So let's look at this. If you want to do this on the back, this is a short answer. That's what I'm thinking about doing. Do you agree to this? If we get through reviewing early, would y'all want to do the short answer part on Wednesday and then do multiple choice on Thursday?
Yes.
Like I can review part up here and then give you the 5 short answers. You do those, and then we just do the multiple choice test on Thursday. Are y'all good with that?
Yes.
Okay. So you know you need to study this short answer. Yes, sir. All right. Number 2. I was getting worried there. You missing some good, valuable instruction right here. What you just said? Yes, sir. That's a good answer. Okay. Let theta be an angle in quad 3, such that tangent of theta equals 4/3. Find the other 5 trig functions. Okay. This is really easy. Don't miss this. Draw your coordinate plane. This is quad 3. Remember, draw your triangle. Alright, in quad 3 tangent. How is okay, your theta always goes right here at the origin. Now, what is tangent defined as in a right triangle? Opposite over. So where would I put the 4? Right here, wouldn't I? But this is where it's tricky. It's in quad what? 3. They're both what? Negative. But you see, it looks like positive. But isn't a negative divided by a negative positive? So you got to think of what quadrant, both your x component and your y component. We're on our semester exam study guide, number 2, back of it, short answer part. You're going to have to do one like this. This is not multiple choice. All right, so this would be opposite -4, -3. How would I find the hypotenuse through what theorem? Pythagorean theorem. So that's going to give me 5. Your hypotenuse is always positive. Now you want to find your other 5, so you need to find sine theta. Sine theta is opposite over hypotenuse. If sine is that, what is cosecant? -5 over 4, isn't it the reciprocal? Cosine would be what? Secant would be. Very good. Tangent was 4/3, so cotangent would be what? 3/4, and that's your answer. Now, question, what if you had radicals here and you ended up with a radical and denominator? Would you have to rationalize? Yes. Now, one thing is, Mr. I need more practice with this. Well, on this study guide, that's 6.1. That's converting degrees to radians and radians to degrees. If you need more practice on that, that's at second bullet, page 499, 47 to 53 odd, okay? If you need to practice that some more, okay? And I think in the video, if you're just coming in, I found a video from last year with a 55-minute to an hour video that's some more problems that reviews that I will post by the end of the week. But that's our review today. Are there any questions? We good? Okay. So we reviewed chapter 5 and 6. Yes, sir. Okay. Calculator. All right, now, what we're going to review now is what we learned on Monday. I did the video on Tuesday to help you better understand it. Okay, well, we're going to go over it for a little bit more, but then we're going to go into our shortcuts for derivatives today, okay? So, on Monday, we started the second main concept of calculus, the derivative. The derivative is the AKA slope generator. It is the formula that you can use to find the slope at any given instant on a function. And that slope at any given instance is called the what? IROC, instantaneous rate of change, isn't it? The IROC, the instantaneous rate of change. What is occurring at that very, very instance, okay? What is the definition, the formal definition derivative? The limit as h approaches what? 0 of f of x plus h minus x over. Very good. So on number 16 here. On number 16 here. We're given this function, negative 5x plus 3. That's a linear function. Here's your definition. We made up of two parts, f of x plus h, f of x. We need to go find those to plug them back into the formula. F of x plus h, whatever's in that parentheses, you plug in for your variable. I get negative 5x minus 5h plus 3. Okay? I'll take that, plug it here. F of x, take x, plug it in, does not change it. That minus is part of the formula. What does that minus do to everything? Changes the signs, okay? So that's going to be plus 5x minus 3. Those cancel out. Get negative 5h over h. Now, remember, at this step, anything that doesn't have an h should cancel out. It did. I'm left with that. I take 0, I plug back in, it still doesn't work. But because there's no plus or minus here, can't I cancel those h's out? Yes. So I'm left with negative 5. So my derivative, remember, you can see f prime of x. Could you see y prime? You remember that other notation, dy over dx? That means derivative too, okay? So there's three ways you can see the word derivative. F prime of x, y prime, dy over dx. Now, I did this notation because it started with that, okay? If it had been y equals, I would have used y prime, okay? Now, that is my derivative formula. You said, Mr. Fisher, there's not much of a formula. No, it's not, because there's nowhere to plug something in, is it? So if I'm concerned with what's going on, what is the instantaneous rate of change at x equals 1? I take 1, I plug it in. Is there anywhere to plug it in? No, so my answer is negative 5. Same thing for 4. So my slope for the tangent line at these two instances, the IROC, are negative 5. What does that negative slope mean? That's what's happening with the graph there. It's decreasing. It's decreasing. Okay? Does that make sense? Okay. On your test on Tuesday, the first page is 6 questions. 4 that you have to do the long way like this. Okay? The 5 and 6 questions say, okay, refer back to question number 2. What is the slope of the tangent line at x equals 3? You got to give the answer and say, is the graph increasing, decreasing, or turning? You got me? So you got to know what you'll be able to interpret it based on your answer. Number 20. We're given a what type of function here? What type of function is this? Quadratic. We want to find the derivative of this. The derivative of this quadratic function. We have our definition. I need to find this and I need to find this. So I come over here to the side. Whatever's in parentheses, you plug it in for your variable. Now, if you are having trouble, well, how am I getting what this is equal? I went down. I did the FOIL method. X times x, x times h times x, h times h. Got that. Distributed to negative 4 plus 7. That part goes in for this. F of x, take x, I plug it in. It's right here. What does that minus do? Changes sign. When you get to this step, everything that doesn't have an h should cancel out. It did. And down to this. As h approaches 0, I take 0, I plug it in, still a no-no. So like I said, what toolkit strategy that I learned in last unit? Factoring, rationalizing, or find a common denominator. Well, factoring's calling my name right here. So I'm going to factor out of h. I'm left with 2x plus h minus 4. These h's cancel out. Now, h approaches 0. I plug 0 in for h. I'm left with 2x minus 4. That's my derivative. F prime of x equals 2x minus 4. That is my slope generator for the tangent line. So I want to know what is the slope of the tangent line at 3 halves. I put F prime of 3/2. I'll plug it in there. 2 times 3/2 minus 4 gives me 3 minus 4, which is -1. So at this moment in the graph, this graph is what? Decreasing. I want to know what's going on at 2. Plug 2 in for F prime. I get 0. The graph is what? And when I mean turning, it means it's either going from increasing to decreasing or decreasing to increasing. There's a maximum end going on right there, okay? Does that make sense? Those two are pretty easy. Now, continuing on, I had 2 examples in the video that supported the next 2. Alright, number 24. This one's not hard, it just looks ferocious, okay? But it's not, these look ferocious, but it's nothing that you don't already know. It's just applying everything, okay? F of x equals square root of x. We have our definition. We need to find f of x plus h. Here it is, I take it in, that's all I can do with that. So I'll put that here. F of x, take x, plug in, doesn't do anything, so I'm right here. But when I get to this point right here, when I get to that point, I take 0 and do direct substitution. I get 0 in the denominator, so that's still a problem there. However, I look at my toolkit strategy. You can tell rationalizing is calling your name. So I'm going to rationalize the denominator. This is mine, so I'm going to make plus plus. Now don't let this get you. I'm on 4. This times this cancels out the square root. That's why I got x plus h. A positive times a positive is why I got a positive. These two ferocious things together right there. A negative times a positive is a negative. Don't your middle terms always cancel out there? By now you should know that. So that's why I don't stress about that. A negative times a positive is a negative. Those square roots cancel out. You're left with x. And then distribute the h. Take a moment to make sure you understand that. Up to that point. Now I'm not giving you any tonight of this to practice, so we practice this for 2 nights. But if you want to go back on that sheet and do a couple on your own and let me check it tomorrow, be well, and I can do that for you. Like coming through here, I can check it. But now we're going to do one of these every day together in class. If you still just want to practice, you can. Okay? But only pick the ones like I gave you now. And I'm not going to give you any very, very complicated ones. This is just testing your endurance, if you can get through all this. Okay, so we're good here, guys? So at this point, everything that doesn't have a h should cancel out. Well, that canceled out. These x's canceled too, didn't they? So I'm left with h over this. Okay? I take 0, I'll plug it in, I still get a no because anything times 0, 0 in the denominator. So I have to try another toolkit strategy. So I'm going to factor here. So I factor the h out in the denominator, and I'm left with this plus this. These h's cancel. I'm left with 1 over this. Now I'm going to try direct substitution one more time. Plug in 0 for h. Not for x, for h. Okay, so x plus 0 is what? X. So are these, can I combine these radicals? Yes, because they have the same thing under the radical. So that's going to be 1 over 2 square root of x. So that is my derivative for that problem, aka slope generator. So I want to know the slope of the tangent line at x equals 25. Plug 25, square root of 25 is 5. 5 times 2 is 10. At 100, square root of 100 is 10. 10 times 2 is 20. So I get 1/10 and 1/20. They're both positives. That means the graph's what? Increasing. Very good. Alright. Number 26. F of x equals 8 over x. Got our formula? We need to find what f of x plus h is. Well, that's pretty easy. 8 over x plus h. F of x is just 8 over x. So I take that and plug that here. And you can go and see what's coming. You got to find the common denominator. It's not hard to recognize that. Take 0, plug it in. Does not work, of course. I'm going to come over here and find the common denominator. We're subtracting fractions. Your common denominator between the two will be x times x plus h. This is missing an x, so I multiply that. That's how I got 8x. This is missing an x plus h. Multiply that and distribute. And I get this. Anything that doesn't have an h is going to cancel out like that. I'm left with that over that. So I take this, I put it back in the numerator. That's what I got from doing that. It's right there. Divide by h. Well, I need to write that out to see what's going on. So I divide by h, multiply by reciprocal. The h is canceled out. I'm left with negative 8 over x parentheses x plus h. Right there. Stop right there. Are there any questions so far? Alright, now I'm going to do direct substitution. 0. X plus 0 is what? X times x is? That's how I got my derivative to be negative 8 over x squared. Okay? And I want to know what's going on at negative 2. Plug that in. Negative 2 squared is 4. Negative 8 divided by 4 is negative 2. That means the graph is what? Decreasing. And the other one, you get negative 8. So that means the graph is also what? So that's my derivative, and that's my slope of my tangent lines at those two spots in the graph. That's your IROCs. Instantaneous rate of change. Y'all feel better about this now after we done? Yeah. You good?
Yes.
I need a hand signal how you feel so far. Like I said, give me a hand signal.
Oh, I thought you said.
Thank you. Thank you. Okay, good job. Alright, now, I'm about to show you the shortcut way now. Turn to page 23. You're going to say, Miss Chester, you made us do all that. Yes, because it's going to make you appreciate this. All right, you don't have to memorize rules. I'm going to teach it to you. You're going to learn it. Okay. The derivative of any constant, just plain old constant, is 0, okay? So that means if you have the derivative of a constant, this is the derivative of that would be 0. So if I ask you derivative of 1, derivative of negative 1 million, it is 0. So the derivative of any constant is 0, okay? So if I ask you to find the derivative of y equals 5, y prime would equal 0, okay? The derivative of any just plain single variable like x, n, r is 1. I'm going to come back to that one in just a minute and tell you why that makes sense. Now here's this. Let's say you had something like this. How do you find the derivative of this? Watch this now. You bring your exponent down and multiply by the number sitting right here. What's the understood number right here? 5 times 1 is? And subtract 1 off your exponent. What's 5 minus 1? That's your derivative. Okay, hold on. Alright, so watch this. This one's easy. Derivative of any constant is 0. Now, do you understand why I use my notation like I did over here? F of x, I put f prime of x. H prime, now it's y, I just put y prime. Do you see that? Whatever they give you. Now, let's go back to why this is 1. What's the understood exponent right there? 1, isn't it? What did we just do? We said 1 times what? 1, which is 1. Then take 1 off your exponent. What's 1 minus 1? Anything raised to 0 is what? That is why any just single variable is equal to 1. Oh, can't say, sorry. Okay, if I gave you x, what's your understood variable? We find our derivative. What's 1 times 1? Okay. And then take 1 off this. What's 1 minus 1? So x to 0 is what? 1. Anything raised to 0 is 1, isn't it? 1 times 1 is 1. That's why any variable, just single variable, has a derivative of 1. Okay? This was about to really upset you. Hold on. I'm going to go back to one of our homework problems. You ready? We're going to do this in one step. Now, you did all this work to come up with the answer of 2x minus 4. You ready? Let's take each one. Take each part. That's 2. What's understood right there? 2 times 1 is? Take 1 off that exponent. It's going to be what? X to the what? First. Okay? 1 times negative 4 is? 1 minus 1 is? Do I need to worry about that variable? And the derivative of any constant is what? Did I get the same answer? There's your shortcut method now. Does that make sense? But you have to appreciate the definition. So on the test, could you check your first 4 with the shortcut? Yes. Okay. Now this other stuff right here is going to get you confused. So I'm just going to show you how to do it on the example. Okay. Okay. Let's find the derivative of this. What's 5 times 7? 5 minus 1 is 4. That's my derivative. So 5 times 7 is 35. And take 1 off your exponent. I use f prime because it's presented in f of x. Now here, h of t, I'm going to do h of prime of t. I'm going to say 2 times what? Which is negative 32. Okay. Take your exponent, multiply it by the number in front. 2 times negative 16 is negative 32. Now take 1 off your exponent. 2 minus 1 is? What's 2 minus 1? So I got t to the first power. You see that? Now, what's your understood exponent here? 1 times 30 is? 1 minus 1 is? Do I have to worry about t to the 0? No, because it's equal to what? 1. And what's the derivative of any constant? 0, so that's your derivative. Does that make sense? Now, yes, they get harder next year in calculus, but this is just the very basics of derivatives, okay? Now, let's talk about the derivative of sine and cosine. The derivative of sine is equal to cosine, okay? You just need to know that the derivative of sine is cosine. The derivative of cosine is negative sine. Those are the two you got to memorize. Yes, the other ones are coming next year. We're just doing these two this year. So sine, the derivative of sine is cosine. The derivative of cosine is negative sine. Now, you said, Mr. Esther, how do you handle this? You don't have to worry about the number in front of sine and cosine when you find the derivative. You just worry about the trig part, okay? So if I ask you to find the derivative of 4 sine theta, it's just 4 cosine theta. You just take the derivative of the sine part. You said, Mr. Esther, well, why did I not take the derivative of the 4? The 4 is part of it. If it had been 4 plus sine theta, the 4 would have gone away because derivative of 4 is 0. But you see how it's there with it? So that's why you keep it. So it's 4. So you're going to do f prime of theta equals 4 cosine theta. The 2 is with it, so it's be y prime equals, notice my notation, it's presented in y, I use y prime. So what would that be? Negative 2 sine, because remember, the derivative of cosine is negative sine, so negative sine times 2 is negative 2 sine. Why, is there a question?
No, I was wondering why you didn't use secant.
No, that's the rule. The derivative of sine is cosine, derivative of cosine is negative sine. That's just the rule.
I got the trig rule, not this.
Okay, gotcha. Yes, buddy?
Never mind.
All right, so let's look at this. So we're going to do these examples today and then call it a day. Number 1, I'm going to write s prime of t. How will I do this? I'm going to say 5 times what? Negative 1, which is what? Negative 5, t to the what? 4th. That would be your answer. So you bring this down, take 1 off the exponent. Now you're going to learn something next you call the antiderivative instead of subtracting when you add them. But that's going to become next year, at the end of the semester. Antiderivatives. All right, number 2. How would I first write this first part? Y what? Prime. What's the derivative of 7? Thank you. Number 3. How would I write that? F what? Prime of x equals. Now, when they're separated by plus or minus, you're going to take the derivative of each part. What's the derivative of the x cubed part? 3x squared. Very good. 3 times 1 is 3. 3 minus 1 is 2. What is the derivative of the negative 4x? Negative 4. What's the derivative of 5? 0. There's your answer. So, if I wanted to know what was the slope of the tangent line at negative 5, how would I find it? This is your plug negative 5 in for what? X, just like you did in the other lesson. That's your IROC, isn't it? This is your slope generator. That's the formula to find the slope of any tangent line in the graph. All right, number 4. Now that's written kind of funny. How could I rewrite that to mean the same thing? 1/2 sine. So let's first write it as 1/2 sine. Sometimes you have to rewrite them. Now, since there's no plus or minus, that 1/2 stays, don't it? What's the slope of sine? I mean, the derivative of sine? Cosine. So y prime equals 1/2 cosine x.
Do you have to put the x in?
Yes. The x.
Would you take
No, I was talking about
cosine
like
x over 2?
It could be like one.
No, we're not. That makes the same thing. That's good. Now, number 5, I got to ask you this: is pi a variable?
No.
No, that's a number, isn't it? So 2 pi is just like a constant, isn't it? So y prime equals what? 0. Y'all like this way better?
Yes.
All right, we're just spending today and tomorrow on this. Okay, number 6. Y'all should know that. Look at it. When it's just a single variable, what is your derivative? 1. Very good. Number 7. That should be easy. What is that? 0. Okay. Number 8. The first part. How could I rewrite that first part? X to the 4th. So I'm going to write that above it, okay? Now, bring the exponent down. 4 times negative 1/2 is what? Okay. G prime of x, that's going to be negative 2x what? Cubed. Because you took 1 off the exponent. What's the derivative of 3x cubed? And derivative of negative 2x would be what? That's your derivative.
That's so loud.
You like this, Ivy?
I love this. This is awesome.
All right, number 9. They're separated by plus and minuses, so you're going to take the derivative of this first part and the derivative of that. What's the derivative of x? 1. Very good. What's the derivative of cosine?
Negative sine.
Very good. So that'd be y prime equals 1 minus sine x. And I put minus because it is negative. 0 is just a number. So what's your derivative of 10? 0. Very good. Derivative of a constant is 0. Mason, you like this? Okay. Now, since there's on number 11, since there's not a plus or minus, do you keep that too? Yes. What's derivative of sine? Cosine. So that's be 2 cosine x. Y prime equals 2 cosine. It's very important to put that prime notation. Number 12. Do you need to rewrite that one? Yes. 1/2 x. If you got 1/2 x, what would be the derivative? 1/2, because 1 times 1/2 is 1/2. 1 minus 1 is 0. X raised to 0 is 1. All right, number 13. F prime of x. 4 times 1 is 4x what? Cubed. They're separated with plus or minus, so you need to find the derivative of each one of those. Okay, I did that part. What's 3 times negative 3/2? Be x what? Squared. 2 times 2 is 4x. 1 times 1 is 1. And that would be your derivative, because negative 6 is a derivative of 0. All right, number 14. F prime of x. What's the derivative of this first part? What's the derivative of 4? 0. That's your answer. Have you noticed that we bypassed pre-AP breakdown there? And we covered 2 units? All right, number 15. What do you think we would do on 15 to begin with? You need to distribute it. You need to figure out what you're really working with. So, x times that would be 2x to the what? 8th. You're multiplying, so you add exponents. Plus 4x to the 5th. Now, g prime, 8 times 2 is? 5 times 4 is? That's your answer.
When you add or multiply, I suppose. No, it's a power to power.
Power to powers when you multiply. Alright, number 16. Take each part. F prime of x equals 12x to the 5th. 3 times negative 1 is negative 3x squared. And derivative is negative 102 is 0. So you just have 12x to the 5th minus 3x squared. Now I want you to think about number 17 for a minute. Sometimes you have to do this. What do you think we might need to do on 17? Because they all have an h in it, don't they? I mean x. So can't you take an x out and then cross those x out and you don't have to deal with that situation? Yeah, let's do that there. So on number 17, I'm going to take an x out. Cancel that out. I'm really dealing with, I'm simplifying it before I start. You see that, Luke? I simplified it. Okay. Now, I'm on to the derivative. H prime of x. 3 times 4 is 12. Take 1 off. That's minus 1 is 2. 1 times negative 3 is negative 3. 1 minus 1 is 0. And then derivative 5. So my derivative there is 12x squared minus 3. Did you realize this is our last lesson for the year? This is the last learning target for the year. Garrett, don't celebrate too much. This year's last math lesson in high school. Well, it continues on with the lesson. It continues on.
Mr. Hester, you're absolutely good.
Thank you, Ivy. Thank you, Ivy. All right, you've had enough snacks throughout the year. I'm broke for the month. All right, here we go. Let's do this last one. Okay, g prime. 1/2 times 2 is what? 1. 1/2 minus 1 is negative 1/2. 1/3 times 6 is what? 2. 1/3 minus 1 is negative 2/3. 3/2 times 2 is negative 6/2, which is minus 3. Okay, I subtracted 1, got negative 1/2. Subtracted 1, got negative 2/3. Subtracted 1, that gives 1/2. Do we understand how I got these numbers here? Now, do I like negative exponents? So you do need to come under here and put it like this. And you can leave it like that. Yes. So negative 1/2, put it in the denominator 2/3, and just leave it like that. You don't have to go any further than that. Now, I do want you to turn it over and let's look at what we're doing tomorrow for just a second. We're not going to continue on, but tomorrow, you see a lot of radicals? Do you remember that math workshop where we had to rewrite things to like positive, negative fractions for radicals? That's why we did that third 9 weeks. So when we got here, you would know how to rewrite stuff, okay? So like here, you have to rewrite this to like x to the negative 2 so you can bring it down. So that's what we're doing tomorrow. So that's the only difference is learning how when it's important to rewrite stuff, okay? So we're going to do this page tomorrow, but your homework tonight just does very basic like this. Is page 29, the whole page. It won't take you long. And if you need to review that other stuff we've been doing, you need to do that as well, okay? You can start on it now. Start on it now. Okay. Get your mind going for second period. Yes, Cindy.